Hello guys, this is Code and Code, and this is video editorial for the problem pluses and minuses taken from educational round 90, and the problem was C. So the problem is we are given an algorithm or pseudocode of the algorithm, and we have to print the final value of the result. So result is initialized with 0, and then we are running a loop from 0 to infinity. INF is defined to be infinity. Now we are also given a string which s which contains only the characters plus or minus. Now we would run we would run a loop from 0 to infinity, and for each initial value we initialize the current value to be initial value of the outer for loop, and then initialize the bool variable OK to be true. After that we'll run for each character in basically we'll run a for loop again from 1 to size of string, and each time when this for loop runs, result is incremented by 1. As you can see, result is result plus 1, and because of this result changes and we have to print the final result. Now if the current character in string as is plus, of course we would increment current variable, otherwise we would decrement it. And if the current value is 0, then we would set the OK bool variable to false and break. If the bool variable is true, then we would come out of this outer for loop as well, and that is where our algorithm stops. Now let's name this something so that understanding this algorithm becomes easy and to calculating the result. Let's call this let's call this algorithm a game which is called survive if you can. Now see, this is a game, and what is happening here, your health is either being increased or decreased. Now this is your initial health, so current is actually your health, and you are playing the game, and each time either your health will increment or decrement, and if your health goes down below 0, you die. So basically you stop there. And why I'm calling it survive if you can is that if throughout this for loop, basically running through the whole string, if at not even a single place your value goes below 0, that means you are able to survive the game. And if you are able to survive the game, that means the bool variable OK is actually true, and it basically never went false. And if that happens, then this outer for loop will break. Basically, if you are able to survive the game from 1 to the string length without your health getting below 0, then you stop. So basically we have to find the minimum initial value on which we are able to survive, because if you can survive, if the first value on which you can survive is x, so from 0 to x minus 1, you won't be able to survive. So this is the game, and finally we have to print the result. Now let's see how we will do that. Now I'll be taking this snapshot of this algorithm so that I can explain you the algorithm that we will be working upon. Suppose this is the example test case of the problem itself. So the example test case is minus minus plus minus. This is the input string. Now so we have to find the minimum health on which we are able to survive this whole game, right? So to find out what is the minimum health on which we can survive this whole algorithm or the game, let's calculate something, the total difference. Now see, if you this basically represents the prefix sum till position I. So prefix sum till position 1 is minus 1, till position 2 is minus 2, till position 3 is minus 1, till position 4 is minus 2, because so this is basically replace all of the negatives with minus 1, all of the positive with plus 1. So this would represent the prefix array. Now how this prefix array is going to help us is that, you see, if you take the initial value, suppose 1, so can you survive this starting from 1? Can you survive going till the end of the string? The answer is no. Why no? See, the initial value is 1, so as you land on this, the overall change is minus 1. This at index I, the value actually represents the overall change in your health. So if the initial value is 1, if you reach this point, the overall change in your health would be of minus 2. So 1 minus 2, 1 which was your initial health, and this is the total change. So 1 minus 2 would become minus 1. Minus 1 means this condition getting true. Basically you are not able to survive at this index if you start with health 1. Of course, if you start with health 1 and you are not able to survive, so of course you won't be able to survive on 0 as well. So this represents monotonic property. So you can also apply binary search to find the minimum health on which you will be able to survive. But actually binary search is one of the solution, but we actually do not need binary search. So you won't be able to survive on 1, you won't be able to survive on 0, you won't but you would be able to survive on 2. Why? Because see, the maximum change that can happen to your health is -2, which is the minimum value, right? So all we have to do is find the minimum value. So the maximum change that can happen to your health, the maximum negative change that can happen to your health is -2. So if you start with health 2, the maximum lower point you can get is 0. You won't be able to get below that. The minimum current health value would go down to 0, not below that. If the minimum current value goes to 0, not below that, that means this condition will never be true. If this condition is not true, that means OK will always be true. And if OK is true, that means you will be able to survive and this outer for loop will break. So basically you have to find the minimum value, and that is the initial health on which you will be able to survive. So basically your for loop will end at value 2, right? So you won't be able to survive on 0, you won't be able to survive on 1, but you would be able to survive on 2. But now that we know okay how to find the on which value of current this for loop will end, but even though we are not able to survive on 0, but because of 0 this increment happens, the result changes. How is that so? See, when the current health is 0, we come here and this would run no matter what. So result would be incremented by 1. So result would become 1, sorry, because it is 0, so it would become 1. After that you will see okay the initial value is minus, so you would decrement 1 from your current health, which is 0. So 0 minus 1 is -1, so you would stop. So this for loop stops. So for current health 0, result changes by 1. For current health 1, result will change by 2. Why is that so? Let me show you. So see, first we have found the minimum value, and then we have taken the absolute value of that. So basically we would be able to survive. The first health on which we would survive is 2, sorry. So we would take max to be 2 and result we would initialize this 0. Let me show you code till now so that we are on the same page. So this is AR. I do not know why I took this. I initially took this for, I was thinking to solve this problem using binary search, and that is why there is a function. And this we actually do not need this, just ignore this. This is map, and this is most important thing I'll be explaining you in a moment. So LLI is long int, basically 64-bit integer in C++. So T is the test case, result is what we would be printing. This is the input string, and after each test case we are reading the input string and also clearing the map. Map is important thing. I'll be telling you why we are using here just a moment. So result is initialized with 0, maximum, which is basically the max value, maximum is initialized with 0, and count, which is basically prefix sum, is initialized with 0. So we are running a loop for each character in the string. So ch represents the current character. If current character is negative, so of course you would decrement the count, otherwise you would increment the count. If just ignore this line, because this was, if I would this was for the case if I had to solve the problem using binary search, so just ignore this. So if the count is less than 0, because we are only interested in negative values, because if the value is not negative, of course that is not going to reduce your health, and at that point you won't be able to die, right? You will be able to die only on those points which are negative, of course. So that is why we are only interested in negative values. So if count is less than 0, yeah, at this point you need to know what is map. So map mp. So let me show you. So first of all 0, for each value, of course we need to know for each count 0 to mx, for each current value from 0 to mx, how much value is incremented by that health. So for health 0, how much value is being added to result. For for I is equals to 0, value 1 will be added into result. Why? Because for I is equals to 0, I'm able to get to basically I'm dying on position 1. If you are dying on position 1, that means you will be incrementing value 1 on result. Why? Because on position, when you come on position 1, you are incrementing result by 1. Where when you are able to survive on position 1, you are going to position 2, and when you are going to position 2, of course you are incrementing the result by 1 again. So if you are dying on position X, so the result will be incremented by X. So for each health from 0 to mx, we have to find the point at which we will die, right? So for value 0, we will be dying on position 1. So since we are dying on position 1, because on position 1 the current health will go below 0, and this is the point where we will die. So for I is equals to 0, we are dying on position 1, so result will be incremented by 1. Now for I is equals to 1, we are dying on position 2. Why? See, when I is equals to 1, basically your health is 1, so you would come here, so result would decrement by 1, so your result is 0. So you are not dying on this position, you are dying on this position. So you would go here, current health is 0 because this decremented it by 1, so current health is 0. So you are decrementing again, so now the current health becomes below 0. That is why you are dying on position 2. Basically, if your current health is X, then you will be dying on position which have value negative of X plus 1. So for I is equals to 1, basically your initial health is 1, so you would be dying on negative 2. So we have to find the first position on which negative 2 appears, because you won't be able to survive here, so there is no way you can go here, so you would be dying here. So we, for each health we have from 0 to X, we need to know, from 0 to mx, we need to know what is the first appearance of negative of X plus 1. So basically if you see here, for 0, the first place where it will die will be the value 0 plus 1 negative. Negative of 0 plus 1 is actually minus 1. So first appearance of minus 1 is at position 1, so it would be dying on position 1. Similarly, for when I is equals to 1, so you have to find the first appearance of minus 2. So first appearance of minus 2 is this. So first appearance of minus 2 is at position 2, so the result will be incremented by 2. And of course you will be dying here. You can take an example. Now when I becomes 2, of course the value will be incremented by n. N is the size of the string, because it dies nowhere, it survives all of the cells. So this for loop runs exactly the string length size, and that is why when I is equals to maximum on which we are surviving, we can simply add in result the string size. So for each value I from 0 to less than mx, we need to find the first appearance of I plus negative of I plus 1, right? So that is the reason I am having a map. The map would store the first appearance of any negative value. For example, in the map for minus 1, I'll be having value 1, because at position 1, the first appearance of minus 1 is at position 1. For minus 2, I'll be having position 2, because the first appearance of minus 2 is 2. And that is what we need. And this basically returns that thing. I'll be explaining in a moment. So now you know the map stores actually the first appearance of any negative value. So now this count increment or decrement. So if count goes below 0, that means it becomes negative. Then we will see whether we have already stored the position for minus 1 or not, or basically count or not. So we'll see whether in the map count already exists or not. If we have already saved it, that means the first appearance we have already saved. So if mp.find, mp which is the map dot find is equals to mp.end, this in C++ this is map, this would return mp.end if in map count is not stored. So if count is not stored in the map of count, we would be storing the position, since it is 0 base index system, but we want the result in the 1 base index system. That is why I'm storing I plus 1. So basically mp map stores the first appearance of any negative value. And now I'm minimizing the max value so that I can find the maximum negative value. After that, since this is negative, just multiply it with minus 1. So now you would run a loop from 0 to mx minus 1, because for mx you won't be able to find any position on which you die. So in map there would be no position for mx. That is why we will be running a loop from 0 to less than mx, and for mx we are directly going to add the result string side, right? So for each health I, it would be dying on that index on which the value stored is negative of I plus 1, as already explained in the slides. So that is why we are calling the function get count, which with the key negative of I plus 1. So this does nothing, just returns the index index of the first appearance of the key, which is negative of I plus 1. So this was all for this lecture. Thank you guys for watching. If you have any doubt or query, of course you can ask in the comment section. And yep, this was all for this lecture, and see you guys in the next lecture. Thank you.